a GP is a sequence, okay? A GP is a sequence in which the next term is formed. Next term is formed by multiplying a constant amount. So by multiplying a constant amount to the previous term. All right, so that's basically what a GP is all about. It's a sequence. So a GP is a sequence in which the next term is formed by multiplying a constant amount to the previous term. So this time around, we are dealing with multiplication as well as division. So examples of a GP, we can have 2, 4, 8, 16, 32, and so on and so forth. So as you can see, there is a certain pattern. No wonder we've emphasized to say it is a sequence. In the first lesson, we defined what a sequence is. We said it's a set of ordered numbers where a pattern exists. As you can see, there is a pattern here, and the numbers are not arranged anyhow. They are following a certain order. So now, here, we are not using multiplication. We are not using addition and subtraction. So this time around, there is multiplication and division that we have to look for us to know which one is the next term, which one is the previous term, and so on and so forth. So if you look at the first term, from the first term to the second term, from 2 to 4, okay, obvious you can guess and say they added a 2. But from 4 to 8, did they add a 2? No. So addition is not working out here. So 2, 4, 8. So from 2 to 4, there was a multiplication of 2. So multiplication of 2. Again, from 4 to 8, there was a multiplication of 2. Multiplication of 2, 16 by 2, they arrived at 32. So if you multiply this 32 by 2, you end up getting a 64 as your next term. So this is an example of a GP. So in this same example, these two that we are using, this time around, we call this one the common ratio. Okay, this is the common ratio, and it is denoted by the variable r. Okay, this is known as the common ratio, and this 2 here is the first term. So this still stands as the first term. So the 4 is the second term, the 8 is the third term, and so on and so forth. So the common ratio here is what we are using to arrive at the next term. All right, so let me give you an example on GP. Suppose you have, okay, let's use the same sequence that we have. Suppose we want to find the seventh term, for instance. Okay, want to find the seventh term. 1, 2, 3, 4, 5, 6. Okay, for us to get the seventh term here, we can simply multiply 64. Okay, we can simply multiply 64 by 2, and it will give us 128. So 128 here becomes the seventh term. So if the question says we find the seventh term, it means 128 is the seventh term. How do you arrive at 128? You can simply arrange the numbers in this order. Okay, this is the first, the second, the third, the fourth, the fifth, the 60th, and then the 7th. As long as you are not missing anything, you still land on the answer. But like I said in the previous lessons, it is important for you to again know the formula on this one, because it's not always that they'll ask you to find the first few terms. Sometimes you can be asked to find the 100th term, the 20th term, the 30th term, the 60th term, just like that. How do you find those values? Quite all right, yes, you can be able to do it with a little bit of patience, but when you are considering such questions, time is also important, because you only have limited time in the exam. This is where now the formula Tn is equals to A r n minus 1 applies. So this is the formula that we are going to use in order for us to arrive at the next term. So let's use the same formula to calculate the seventh term. So we are going to say T7 T7 is equals to, where there is A, you press a 2 because your first term is 2. So you're going to say 2, open brackets, the common ratio. So how do you find the common ratio? This time around, for you to find the common ratio, the formula that you use is this one. You can say common ratio is equals to T2 over T1, or you can say T3 over T2, T4 over T3, T5 over T4, T6 over T5, T7 over T6, T8 over T7, T9 over T7, just like